We'll be treating these practical questions based on our topic, numbers and numerations. So if you've not seen our videos on numbers and numeration, please check the channel for the full video. Question 1. Which of the following is a whole number? In our study, we looked at different characteristics of a whole number. And from here, we can see we have a -2, a 1.5, a 0, and a 3/4. So which among these is a whole number? All right. If you've chosen C, then you are correct because 0 is a whole number. Remember that a -2 isn't a whole number. Why? Because our whole numbers are non-negative integers. Decimal 1.5 isn't a whole number because it's in a decimal form. It has a whole number and the fractional aspect. 3/4 is a fraction, and fractions are just part of a whole number. So the only whole number here is 0, which is option C. Question 2. A fraction with numerators smaller than the denominators is called an improper fraction, a proper fraction, mixed numbers, or whole numbers. All right? I give you a few seconds to think over this. Okay? Our right answer here would be a proper fraction. Okay? We have our answer to be a proper fraction, which is option B. Our next question says, convert 0.75 to a fraction. Now, in converting 0.75 to a fraction, we have 0.75, all right? In converting this to fraction, we would divide by the number of zeros. How many digits do we have here? We have 1, 2. 2 digits. So this becomes 75/1, 2. 2 zeros. So the number of digits we have here determines the number of zeros that we are putting below. Okay? Now converting 75/100, now dividing by 5, 5 into 7 will give us 1. Remainder 2, 5 into 25, 5, all over 5 into 100 will give us 20. 5 again, 5 into 15 will give us 3. 5 into 20 will give us 4. So, a 0.75, if converted to a fraction, will be 3 divided by 4, which is our option A. Our next question says, express 25 as a decimal, 25% as a decimal. In our study, we've learned that once we have it as a percentage, it's a fraction of 100. So our 25% simply means 25/100. Okay? So now, if we have it as this, so we are going to use a long division method, which gives us 25 and 100. So 100 cannot go into 25, so we add a 0 to our 25 while introducing our point. So 100 into 250 would give us 2. 2 times 100, 200. So 250 minus 200 will be left with 50. And still yet, 100 can't go into 50, so we add another 0. So 100 into 500 will give us 5. 5 times 100 will give us a 500. So our 25% in decimal will be 0.25. So our 0.25 would be option A, would be our 25% expressed as a decimal. Which of these is an example of a mixed number? All right, now when we talk about mixed numbers are types of fraction which has a whole number aspect and a proper fraction. So now when we look at this, we have our first option as 3/2, second option as 2.5, Third option has one whole number, 1 over 2, and the next one is D, which is 5. Now, if we look at all our options, we have one of them as a mixed number. For A is 3 over 2, which is not a mixed number, but an improper fraction. B is 2.5, which is not a mixed number, but a decimal fraction. And D is 5, which is a whole number. And so the correct option would be C, which is one whole number, 1 over 2. That is our mixed number. Now, it says, what is 10 raised to power 0? Now, in indices, whatever number you have raised to power 0 equals 1. Okay, so even if we have 100 raised to the power of 0, we have it as 1. 10 raised to the power of 0, we have it as 1. 6 raised to the power of 0, we have it as 1. So any number raised to the power of 0, y raised to the power of 0, we have it as 1. So whatever is raised to the power of 0 equals 1. So our correct option here will be option C. Now, our next one says, simplify 2 raised to the power 3 times 2 raised to the power 2. If we have 2 raised to the power 3 times 2 raised to the power 2, all right, we can decide to apply our law of indices, or we decide to go by expanding it. Now, looking at both ways, if we have applying our law of indices, which is 2 raised to the power 3 plus 2, this will give us 2 raised to the power 5, all right? Or we can say 2 raised to the power 3 simply means 2 times 2 times 2. And 2 raised to the power 2 means 2 times 2. So when we count all our 2's, we have it as 1, 2, 3, 4, 5. So this still becomes 2 raised to the power 5. So either ways, you are still correct. So this 2 raised to the power 3 times 2 raised to the power 2 will give us 2 raised to the power 5 as our right answer, which is option A. Now, we have log 10 100 equals what? So if we have log 10 100, okay, now this, first off, so you can break down our 100 to be in the power of 10. So we know that 100 equals 10 squared. Why? 10 times 10 will give us 100. Okay, so replacing our 100 with 10 squared, this becomes log 10 bracket 10 raised to the power 2 equals, all right. Now, from here, we can now bring our 2 down by applying our power law. This becomes 2 log 10 10. Also remember that we said when you have log AA, it equals to 1. So that means in this case, our log 10 10 equals 1. So this becomes 2 times 1, which will give us 2. So therefore, log 10 100 equals 2. So our right option there would be option C. It says the decimal of 3 over 5 is, so we are asked to convert 3 over 5 to a decimal. So if we have 3 over 5 to decimal, in order to convert this to decimal, we will put it in a division form. 5, our denominator stays out, while our numerator stays in. Now, 5 cannot divide 3, so we put a 0 and introduce a point. All right? Now, 5 into 30 would give us a 6. So our 3 over 5 would be 0.6 in decimal, which is our option B. Now, question 10 says, express 0.2 as a percentage. So we have 0.2, Okay, expressing it as a percentage, all right, would be, we have 0.2. How many digits do we have here? 1. So this becomes 2 over 10. Since we have one digit after our decimal point, we are having one digit, 10 below, times 100 over 1. Since we are asked to express as a percentage, so in order to express it as a percentage, we multiply the fraction by 100. So this becomes 0 cancels 0, leaving us with 2 times 10, which gives us 20%. So 0.2 as a percentage would be 20%. Which law of indices is used in a raised to power 4 times a raised to power 2? Now, we have the product law, we have the quotient law, we have the zero index law, and we have the negative index law. Now, if we look at our negative index law simply means we have our a raised to power minus n, which gives us 1 over a raised to power n. All right, this is our negative index law. When we talk about the zero index law, our zero index law means a raised to power anything raised to power 0, it's 1. That's our zero index law. Now, when we talk about the quotient law, quotient simply means division. So we have a raised to power n over a raised to power n, okay, which is a raised to power m minus n. All right. Now, that is our quotient law. Now, we have our product law, which is a raised to power m times a raised to power n, which is a raised to power m plus n. So, in this case, our m is 4 and our n is 2. So, 4 plus 2 will give us a raised to power 6. So, the product law, the law that was used here is our product law, which is option A. Next question we have, what is 10 raised to power minus 0? 10 raised to power minus 10 raised to power minus 1. Now, looking at 10 raised to power minus 1 is having it as 1 over 10. All right, and we know that when we have it as 1 over 10, we have it as 0.1 because we have 1 0 here. That means after our decimal, we are only having 1 digit. Okay, so always remember that when you're converting a fraction to a decimal, all right, when the denominator is 10 or in zeros, you just need to know the number of zeros to move your digit. So for here, we have it as, since it's 1 0, that becomes 0.1. 1 digit will be after your decimal. So our right answer here will be option C, which is 0.1. And next question says log 10 1 equals what? So now we have log 10 1 equals what? Okay, if we have log 10 10 as 1, okay, we have log 10 100 as 2, log 10 1000 as 3, okay, so and we have, so they are looking for log 10 1, so log 10 1 will be 0. Okay, our answer will be 0, which is our option A. The fraction 7 over 7 equals what? All right, 7 over 7, okay, equals 1. You have 7 oranges shared to 7 people. Each individual would get 1 orange. So 7 divided by 7 equals 1, which is option C. A decimal number between 0 and 1 is always A, greater than 1, B, negative, C, a whole number, and D, less than 1. Now, it says a decimal number between 0, that means you have your two extremes at 0 and 1. So between your 0 and 1, we have decimal numbers of 0.1, 0.2, and so on and so forth. Now, the question is that your decimal numbers between 0.1 and 1 is it greater than 1? Are they negative? Are they a whole number? Or are they less than 1? Now, we know that once it's greater than 0, okay, any number greater than 0 is less than 1. First, it can't be greater than 1 because it's not up to 1 yet. All right? It can be negative because our 0 is always positive. Now, it can't be a whole number because they are decimal numbers. All right? So our right option here is that they are less than 1. So any decimal number between 0 and 1 is less than 1. Which of the following is not a percentage? Which of the following is not a percentage? Now we have 100%, 50%, 0.75%, and 1.5. Now, among the four options we have here, it is clear that the only one without a percentage sign is our option D. So 1.5, which is a decimal fraction, isn't a percentage. Indices are used to represent A, addition, B, repeated multiplication, C, division, and D, subtraction. Now, the main focus of indices are used in representing repeated multiplication. That's why we are having it as 2 raised to the power 3. We have it as 2 times 2 times 2. Repeated multiplication. A raised to the power 5, we have it as A times A times A times A times A. Repeated multiplication. So instead of multiplying each and every of them individually, we can shorten it to have it as A raised to the power 5. And that is what indices are basically used for. What is 5 raised to the power 2? All right. 5 raised to the power 2. When we talk about 5 raised to the power 2, that means we have 5 times 5. So what is 5 times 5? 5 times 5 is not 10. No, because that's not addition. It's a multiplication. So 5 times 5 will give us 25, which is option B. 5 times 5 squared equals 25. All right. Our next question says, log 10 1000 is, if we have our log 10 1000, all right, we have log 10 1000, okay? Now we know that 1000 is 10 times 10 times 10, which is 10 raised to the power 3, okay? So replacing our 1000 with 10 raised to the power 3 here, this becomes log 10 raised to the power 10 raised to the power 3. All right. Now, having this, we can now bring down our power down here. This becomes 3 log 10 10. Bearing in mind that our log 10 10 equals 1. So if we have our log 10 10 equals 1, that means we can replace this with 1. So this becomes 3 times 1, which will give us 3. So our final answer for log 10 1000 would be 3, which is our option C. Now, it says convert 3.5 to a fraction. Now, we are converting from decimal to a fraction. Now, we have 3.5. Okay, we have 3.5 as our decimal. All right, now from here we can see that we have the whole number aspect and we have the fractional aspect. So in converting this to a fraction, still same way of converting, how many digits do we have after our decimal point? 1. So this becomes 35 all over 10. Because we have one digit after our decimal, we are having 1 0 below. Okay, so now breaking this down, 5 into 35 will give us 7. 5 into 10 will give us 2. So our decimal fraction, our 3.5 converted to fractions will be 7 over 2, which is our option A. With this, we've come to the end of today's tutorial. If you haven't seen our numbers and numeration videos, please check the description link below. If there'll be any questions, put them down in the comments section. Thank you for watching.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao, NET, IALT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.